All right, boys and girls, we're going to look at a couple of vocabulary words that are pretty important to fifth grade. A lot of times when we start seeing these two words, you're relating it back to factoring and just kind of some good introduction into your fractions that we're about to really get into. And those two words are prime and composite numbers. And so the first one that we're going to look at on this first screen is a prime number. And the definition is here. It's really simple. It says it's a whole number greater than 1 with exactly two factors, 1 in itself. And so the example here that they've given is the number 97. And so when you're factoring out numbers again, you're thinking, okay, well, what times what gives you that product? And if it is what's called a prime number, you're really just thinking about it having two factors, 1 and itself. And so a lot of times you got to be really careful with prime and composite numbers because there are some things that kind of can get overlooked. There's some things that sometimes kids will kind of relate it to, and they only relate it to something. And I always go back and I tell my kids, well, a lot of times it takes you proving whether it's prime or composite. So again, with this one being prime, only 1 times 97 would give you 97. What your teachers are probably going to ask that you do are memorize the first 12 prime numbers. And so I'm going to list those here just to kind of show you some of the more common prime numbers that pop up. And it just is really going to be beneficial when we get into fractions for you to know this. So I'm going to start with the first prime number, which is actually the number 2. 2 is a prime number because, again, if you were to factor 2 out, you would think, well, only 1 times 2 would give you 2. There's nothing else multiplied together that would give you 2, so 2 is your first prime number. The next one is 3. 3 is a prime number, obviously 1 times 3. And so you kind of start going in a pattern here. The next one would be 5. The next would be 7. And I always tell my students when this happens, it's kind of like, okay, well, kids start going, oh, okay, I see the pattern. It looks like it's just going to be your odd numbers past 2. And so they'll go, okay, well, I know what's next. It's going to be 9. Well, you got to really kind of stop and think. Again, if it's all about proving it and understanding what a prime number is. It only has 2 factors. Well, 9 is obviously going to have 1 times 9, but then it's also a multiplication fact. It's 3 times 3. And so you have to be really careful. And that's kind of what I meant earlier about sometimes kids really, they don't relate it to something and they kind of forget about it. And they're like, oh, okay, well, it's just kind of odd and evens. I know odd and evens from when I was a little kid, but it's more to it than that. I mean, odd and evens will help you out somewhat, but you have to be really careful. And you got to make sure that you have that proof behind it. So 9 is not going to be one of your first 12. You would actually skip 9 and go to 11. Now 11 would be 1 because it's only 1 times 11. So I'm going to keep going here. The next one would be 13. We would skip 15 because of 3 times 5. The next would be 17. I'm going to go underneath. The next would be 19. And usually when we're memorizing them in my class, I always tell kids, okay, so if you can kind of get up to 19, remember that there's 2 in the 20s and there's 2 in the 30s. And so the 2 that are in the 20s are 23 and 29. If you thought about that, 1 times 23 and then 1 times 29 are the only things that would give you those digits. And then when you get into the 30s, it's kind of the same thing. You have 2 in the 30s. And the first one's 31. And then the next one's going to be 37. And so a lot of times this is kind of where I pause and I'm like, okay, well, what do we notice? And most kids are like, well, I see a lot of odd numbers, which is very true, with the exception of 2. So I'm going to put a little star above 2 here and just kind of let you guys know this is what makes 2 unique. 2 is the only even prime number. And so if you know your odds and evens, it could benefit you when you are trying to figure out a prime or composite number, but it's not everything that you need to know. In other words, sometimes I'll tell my kids, okay, well, if that's all you know is your prime and composites or odds and evens, you're going to be in trouble because it's not always just about that. It's about factoring and understanding a prime number only has two factors. And so, yes, if you see an odd number, your first thoughts might be, okay, well, it's prime, which is not terrible to think that way, but you still have to prove it. You still have to factor. Because if it has more than just one in itself, then you've got to, you got to think, okay, well, hey, what are those other factors? And if that's the truth, it's not going to be a prime number. So what we usually have kids do in fifth grade are memorize these first 12 primes. They are the most common that you see. A lot of them will have, you'll see them on a test question, and it's just always good. It's kind of like memorizing your math facts. It's just good to have them in your back pocket if you ever need them, and you can quickly have that information at your fingertips if you get a question about prime or composite numbers. All right, our next slide here is talking about a composite number, and I'm going to read this one. It says it is a whole number that has more than two whole number factors. And it gives an example here for 30. And so I'm going to, kind of use this, what they have here, and just to, kind of prove to you what makes 30 a composite number. There's actually a couple of things that make it a composite number. Well, here, if you look, they've listed out a lot of factors. I mean, if I were to count these, there are 1, 2, 3, 4, 5, 6, 7. It's got 8 factors. And so that is definitely more than 2. And so automatically 30 is going to be a composite number. Something else that makes it a composite number is it's even. And so this is the little trick here that you need to kind of start thinking about, but you got to be careful again with this trick. So every even number on the number line is composite with the exception of 2. 2 is the only prime even number. So I usually tell my students, it's like, okay, if your math, if what they want, if it's a question and if it's prime and composite and it's an even number, and I'm going to write one out here to the side, like 24, then it's automatically going to be composite. Like if that's what they want to know, you got it. I mean, automatically I could say it's a composite number because 24 is an even number. My proof could be, well, it's even, or, well, I can do 1 times 24. I can do 2 times 12. I can do 3 times 8. I could also do 4 times 6. It has quite a few factors itself. But because of my factoring underneath and the fact that it's even, automatically it's going to be composite. So usually the conversation in class goes, okay, well, I get it. Mr. McClure, this is pretty easy. I can go back to my odds and evens. So pretty much you're telling me that every even number is composite, so all composite numbers have to be even. Well, that's the other misconception. That's the other part where you have to be really careful and go, well, hold on, well, wait. Not is it, it's very true, except 2, all even numbers are composite. But that doesn't mean that an odd number can't be composite, because I can put up an odd number like 15 and go, well, if I factored it, that's 1 times 15. But 3 times 5 is also a factor. And if I were to count that, that's 1, 2, 3, 4 factors that give me 15. And that meets the requirements for the vocabulary word of a composite number. It has more than 2 factors. So a lot of times what will help is really, knowing your definitions, knowing what a prime number is, knowing what a composite number is, being able to factor to prove your work, which one's prime, which one's composite, that type of thing. And then a lot of times it just goes back down to facts, because you could be looking at this going, well, hey, maybe a number pops up on a page and maybe it's the number 63. Well, 63 is a little bit bigger number, but I know 63 is a composite number because it's a math fact. 1 times 63 is going to be 63, but I also know that 7 times 9 gives me 63. And so with that being said, that's enough proof for me right there just to label it composite. And so you got to be really careful. Odds and evens are good to know, and it helps, but it's not the only thing that you should know. You still need to know what a prime number is and what a composite number is. And it would be really good to learn your first 12 primes. Sometimes kids are like, well, okay, do we need to learn our first 12 composites? I don't, in my opinion, at least in my class, I don't do that with my students. I think it's probably more important just to be solid on their definitions. All right, so prime and composites, pretty easy stuff. You're really going to use your factoring to prove what's prime and what's composite.